Right, online am I? Is all the DOs perfect? Online am I? Is all the DOs perfect? Perfect, no? Clear, no? All clear? All clear. All clear, right. Right, we are ready to start. Now we are ready to start. Shh, 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 shh. We are ready to start. We are ready to start. We are ready to start. Now it's 9:33. In the hall, we have 170, up to the 170. Zoom 100 past. So at the start itself, 270. I want to tell exactly 1 year before, I had only one student in my class for this batch. Right? Right. So I just wanted to tell that before we start. Right. Again, good morning, everybody. There are some things I want to tell to the physical students. I already told once. 180. Physical students 180 past. Right. Already I told once. The reminders are this. First thing, no beetle leaves. No beetle leaves. No beetle leaves on the table. No beetle leaves on the table. No beetle leaves on the table. Why? Tables are new. Then when you say we should give it new. Otherwise, hereafter I can't do any other seminar. And for the practice, don't write anything on the table. That is one. Books are there. You can write anything you want. Anything you want, you can write. Right. Right. Second thing, don't try to connect anything to the TVs, your mobiles or anything. Surely we'll be finding the person. We can't do anything. We'll have to send it home. In the way, don't go to connect anything to the TVs. Right? TVs are connected so that background user can see. Now, if someone connects it, that means background is only connecting it now. Other thing is, I'll switch off the TVs. Then background can't see from the TV. You'll have to see from this thing, from the screen. That is the other thing. And the other thing, of course, washrooms are there behind. You can use it. Right? Washrooms are there behind. You can use it anytime. But don't waste so much of time. You all know washroom. This is the hall. This is the washroom. Displacement is 5 meters. I know you will try to go through a distance. So go with a displacement. Go with a displacement. Don't try to go with a huge distance. Right. Those are the reminders. Those are the reminders. Right. Now we can start. Electrochemistry. Electrochemistry. Part 2 book. Lamai in O levels, once when we open the part 2 book itself, there's a slight scareness. Why? First lesson, heat. Second lesson, power and energy of electrical appliance. Third lesson, electronics. Fourth, electrochemistry. After that, electromagnetism and electromagnetic induction. Until we pass that lesson, always there is a scareness for most of the students. That's why I wanted to take a difficult lesson and make it easy today. The lesson is electrochemistry. Shortcuts are taught, but important shortcuts are taught, but I want your full attention from the beginning until OBM. I want your full attention. We'll make it a patta day today. We'll make it a patta day today. Online people, of course, you are at the home. Maintain your discipline at the home. Discipline means Lamai, not only the discipline that is told by rules and regulation. You should have your own discipline. I sit for an exam, I sit for a seminar, I should properly sit, I should properly watch. When others talk, I should not talk. You should maintain your proper discipline. Then other game are gone belong. In one day, electrochemistry will be over. In one day, electrochemistry will be over. Right. Electrochemistry. 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 There you go. Electrochemistry. Electrochemistry. So why, sir, it is hard, Lamai? It is because it's not the normal chemistry that you learn. It's a different world. Until A level, already chemistry means. Now suddenly they take you to a different world and they tell something called electrochemistry. Suddenly they start writing equations like this. Sodium changing into sodium plus ion by liberating an electron, they tell it is oxidation reaction. They do not. Suddenly when you enter to this world, you are lost. You are lost. That is why until now you are lost. So before we enter to the world of electrochemistry, we will first train ourselves, then it is more easier to enter that world. Right. There you go. Electrochemistry. What are the concepts you need to enter that world? What are the concepts you need? What are the concepts you need? Concept number one. Concept number one. Oxidation number. What's concept number one? Oxidation number. Simply, what is oxidation number? Listen. Oxidation number is number of electrons gained or number of electrons lost represent with the charge. So I can't understand. Yes, I know. Oxidation number of elements. Look at the board. Oxidation number of elements is exactly equal to 0. Any element you take, what is the oxidation number? 0. That means sodium Na. What's the oxidation number? 0. Oxygen O2. So is it an element? Yes, I taught you. Can you remember? O2, N2, H2, Cl2, F2 elements. That means the oxidation number is 0. N2, what's the oxidation number? 0. Okay, potassium, what's the oxidation number? Cl2, what's the oxidation number? Any element you take, what's the oxidation number? 0. That is the first concept. Next one. If you take a charged ion, what is an ion? The Panasonic iron that you use to iron your clothes, Navy. What is IUN ion? An atom with a charge. What is IUN ion? Atom with a charge. When an atom with a charge, ion, its oxidation number is equal to the charge on the ion. Charge on the ion. That means sodium plus 1 ion. What's the oxidation number? Charge on the ion plus 1. Then you all tell me potassium plus 1. Oxidation number plus 1. Then number Cl minus 1. Oxidation number minus 2. What's the oxidation number? H plus 1. What's the oxidation number? Clear? Then what are the first two concepts? Oxidation number of any elements is equal to oxidation number of any ion is equal to then oxidation number of potassium plus one ion. What's the oxidation number? Oxidation number of potassium. What's the oxidation number? 0. Clear? Any doubts? Take out your books. Write electrochemistry. Write electrochemistry. Session work. Write electrochemistry. Under that, work fast, work fast. Under that, write down oxidation number. First one, concept one, oxidation number. Oxidation number. Where? Oxidation number. Under that, the definition you all do never ask the definition. Oxidation number. Under that, write down elements equal to 0. Today, patta short notes we are writing. So don't go to write long notes. Elements equal to 0. Elements equal to 0. Under that, write down the examples. Write down the examples. Sodium 0, O2 0, N2 0, Cl2 0, K 0. Sodium Na0, O2 0, N2 0, K 0, Cl2 0. Second one. Ion equal to charge on the ion. 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 Write the examples. Ion equal to charge on the ion. Write the examples. Okay. Right. Concept number 2. Concept number 2. Look at the board. What is oxidation reaction? You actually call it oxidation half reaction. Oxidation half reaction. What is oxidation half reaction? Observe. Gamai, there is a definition. Oxidation half reaction is a reaction in which electrons are liberated. What is oxidation half reaction? A reaction in which once when you study the definition, we can't understand anything. I know. I'll teach you the shortcut method. I write oxidation reaction. There you go. Sodium converting to sodium plus ion. There you go, plus electron. Listen now. Listen. Sodium. What's the oxidation number? Y0 element. Sodium plus 1 ion. What's the oxidation number? 0 to plus 1. What is happening to the oxidation number? Increasing. If the oxidation number increases, you call it oxidation half reaction. So this reaction is oxidation half reaction. Now again I'll tell the definition. Oxidation half reaction is reaction that proceeds by liberating electron, giving out electron. Correct? No, sodium to sodium plus ion giving out an electron. Lamai, during a reaction, if something is given out, if something is liberated, you write it in the product side or reactant side. Product side. Why? It's kind of a product. It is liberated out during the reaction. So you write it in the product side, electron in the product side. Never go and write the electron in the right hand side. That means the reactant side for oxidation reaction. You all just think and tell me. If you write the electron in the right hand side, that means liberating electron or gaining electron. Why gaining electron? That is in the reactant side. Reactants means they are gaining that and reacting. So if you write the electron in the right hand side, that is gaining electron. Oxidation is liberating electron. You need to write it in the left hand side. Clear? Understood? Again tell me, during oxidation reaction, what is happening to the oxidation number? Increasing. 0 to plus 1. Oxidation reaction. Electron should be written in which side? Reactant side or product side? Why product side? Because electrons are liberated. Clear? Understood? Another example. Potassium. You all tell the oxidation reaction. Potassium converting to potassium plus 1 ion. Where is the electron written? What is the oxidation number here? Oxidation number here. What has happened? Increase. That is oxidation. Another example. Lamai, zinc forms zinc 2 plus ion. No? Zinc forms zinc 2 plus ion. Just keep in mind. Now tell me. Zinc. Tell me the oxidation reaction. Zinc 2 plus. Now Lamai, how many electrons are liberated? Why 2 electrons? To form plus 2 charge, 2 electrons should be liberated. Plus 2. What's the oxidation number here? What's the oxidation number here? What has happened? Increase. What is that reaction? When you are writing, write for ion Fe. Fe forms Fe plus 2 ion. You are right. Now write down second concept, oxidation reaction. Oxidation reaction. Oxidation reaction. Oxidation reaction. Another write down. During a reaction, tell me, electrons liberated or gained? If electrons are liberated, it is oxidation half reaction. It is oxidation half reaction. It is oxidation half reaction. Take a color pen, put a star and write. Take a color pen, put a star and write. Take color pen, put a star and write. Increase in oxidation number is. 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 Yeah, second point. Increase in oxidation number is oxidation reaction. Or oxidation half reaction. Oxidation number is oxidation half reaction. Write the examples. First, second, online am I all clear, no? All clear, no? First, second, done. Second one, zinc, and then you are right for iron. You are right for iron. Zinc and iron. Right. What can you tell about iron? Iron converting to Fe, Fe2 plus by liberating 2 electrons. There you go. Another one, little bit different. Don't panic, but little bit different. There you go. For chloride ion, look at the board. My 2Cl minus 1 ions will convert to Cl2 by liberating 2 electron. Electron in the reactant side, guaranteed oxidation. But Lamai, what is happening to the oxidation number? Look, forget about number 2. What is the oxidation number of chloride? Chlorine minus 1 to 0. What is happening? Again increasing. Check the number line. Minus 1 to 0 increment. There you go. Minus 1 to 0. This is also what? Oxidation. So don't panic when you see minus 1. Clear? Write it also. Better to use a color pen for that. Right? Right. That's all oxidation half reaction. Next one, look at the board. Third concept. Reduction half reaction. Reduction half reaction. Reduction half reaction. Lamai. Liberating electron oxidation. Then reduction is gaining electron. Gaining electron means electron should be written in the product side or reactant side. Reactant side. Then what happens to the oxidation number? Increase in oxidation number, oxidation. Then reduction, decrease in oxidation. Nothing to learn. Nothing to learn. We will get an example. 2H plus ions gain 2 electron, convert to H2. Forget about number 2. What's the charge on H? Plus 1. What's the oxidation number of H then? What's the oxidation number of hydrogen, H2? Plus 1 to 0. What is happening? Increase or decreasing? Oxidation or reduction? There you go. In reduction, where do you write the electrons? In the reactant side. Clear? Understood? Write down. Write down. Reduction half reaction. Reduction half reaction. Reduction half reaction. Under that write down. Under that write down. Gaining of electron. Gaining of electron. Gaining of electron during a reaction is reduction half reaction. During a reaction is reduction half reaction. During a reaction is reduction half reaction. Shh, shh, shh. During a reaction is reduction half reaction. Reduction half reaction. What's the shortcut method? Decrease in the oxidation number. Right now. Put a star color pen or something. Decrease in the oxidation number. Decrease in the oxidation number. Right now. Decrease in the oxidation number. Decrease in the oxidation number. Write this. You all write the reduction reaction for copper plus 2 iron. You all right. Copper plus 2, you all right. Tell me copper plus 2. How many electrons it should gain? 2 electrons. It will convert to what? Copper. Right. Now, copper plus 2 iron gains 2 electrons to convert to copper. What's the charge? What's the oxidation number of copper plus 2? Oxidation number of copper plus 2 to 0. Increase or reducing? Reducing is what reaction? Clear? That's all. Oxidation and reduction half reactions. Now next important point is oxidation half reaction. Oxidation half reaction. Oxidation half reaction. You give another name, anodic reaction. What reaction? Anodic reaction. Another name is anodic reaction. Look at the board. More important things now. Anodic reaction. Look. Why anodic reaction? Because oxidation takes place at anode. Where does oxidation take place? Anode. So the location where oxidation takes place is anode. Remember, oxidation takes place at anode. Lamai, reduction half reaction. You give another name. What's that? Cathodic reaction. Why? Because it takes place at cathode. Place is only cathode. Person might be cathode, might not be cathode. But the place is cathode. You will understand it when we do electrochemical cells. There you go. This is also called as cathodic reaction. Why? It takes place at cathode. Go to the anodic oxidation reaction. Write like this and keep. Anodic reaction. Right there. Anodic reaction. Put a dash and write anode. Short note. Put a dash and write anode. Put a dash and write anode. So the reduction half reaction, dash and write, slash and write cathodic reaction. Cathodic reaction. Put a dash and write cathode. It takes place at cathode. 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 Right. Next one. Next concept. Concept number 4. Reactivity series. Reactivity series. Also it is called as activity series. Activity series. or even electrochemical series. All the names are for the same person. Reactivity series, activity series. Should we memorize the activity series? Yes. You need to memorize the activity series and keep. So how to memorize the activity series? I'll tell. Potassium separately. Naughty cat might get ulcer, ulcer from Sir, Sir Perory. Sir Perory. Sir Perory. Under this, it continues. His cute Hansi always plays Audi. Potassium separately. Naughty cat might get ulcer from Sir Perory. His cute Hansi always plays Audi. This has a proper meaning. This doesn't have a proper meaning. We made it in 2021 batch. 2021 batch, we made this song. Potassium separately. Naughty cat might get ulcer from Sir Perory. His cute Hansi always plays Audi. Now, what does this activity series tells us? It tells the reactivity order of metals. That means potassium patta reactive, sodium little bit less reactive, calcium little bit less reactive than potassium and sodium. So when you go down, reactivity decreases. Finally, gold. I won't tell it is not reactive. It is also reactive, but reactivity is patta less. Clear? Understood? Now write down reactivity series. Or inside, just write activity series. Let's go with that word. Activity series. Activity series. Activity series. Another write down. Potassium. Naughty cat might get ulcer from Sir Perory. His cute Hansi always plays Audi. Right. Finish. Finish. Right. Now, why do we need to learn activity series? Listen. Lamai, in case if you have several metals, listen now, more important things. In case if you have several metals, for example, zinc, copper, gold. In case if you have several metals, zinc, copper, gold. Out of all these three, only 1% will undergo oxidation. All three cannot undergo oxidation. Out of these three, only 1% will undergo oxidation. Who will undergo oxidation? The person who is located higher above in the activity series. Tell me, zinc, copper, gold. Who is higher? Zinc, copper, gold. Who is higher? Zinc. Then zinc will undergo oxidation. It will undergo oxidation. It will undergo oxidation. Then who will undergo reduction? Reduction also 1% can only undergo. Who can undergo? Gold. Why? The person who is less in the activity series will undergo reduction. Then gold will undergo reduction. Gold will undergo reduction. Gold will undergo reduction. Now you all tell me. Now you all tell me. Sodium, potassium, calcium. Who will undergo oxidation? Why potassium? Higher in the activity series. Who will undergo reduction? Why calcium? Lower in the activity series. Next one. Hydrogen, zinc, copper. Who will undergo oxidation? Zinc. Why zinc? Higher in the activity series. Who will undergo reduction? Why copper? Iron, copper. Who will undergo oxidation? Why iron? Who will undergo reduction? Why copper? Zinc, copper. Who will undergo oxidation? Why zinc? Who will undergo reduction? Why copper? Now clear? Write down. If there are several metals, 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 the metal located higher in the activity series, higher in the activity series, higher in the activity series, higher in the activity series will undergo oxidation. You can watch the video outside. Will undergo oxidation. Second one, second point. The metal located lower, the metal located lower, the metal located lower will undergo reduction. Will undergo reduction. Metal located high will undergo oxidation. The metal located lower will undergo reduction. Will undergo reduction. Up to there, everything clear? What did we do until now? There you go. Electrochemistry. Electrochemistry. We started with oxidation number. Quickly tell me. Oxidation number of elements equal to oxidation number of ions equal to what is oxidation half reaction? When we ask that, what we write? Reaction in which electrons are liberated. But what is our method? Reaction in which oxidation number increases. Sodium, tell me the oxidation reaction. Zinc, oxidation reaction. Iron, Fe, oxidation reaction. What is reduction reaction? Gaining of electron is reaction, half reaction. What is our method? Decrease in the oxidation number. H plus, tell me the reduction reaction. Plus 2 electron converting to H2 gas. Clear up to there? If there are several metals, who will undergo oxidation? Who will undergo reduction? Very good. Now we can start electrochemical cell. That is the first part of electrochemistry. Now we are ready to learn about electrochemistry. First part is electrochemical cell. Write down heading electrochemical cell. Electrochemical cell. First part under electrochemistry. Electrochemical cell. Electrochemical cell. Electrochemical cell. Right. Lamai, what does an electrochemical cell do? By performing a reaction it produces current electricity. But by performing a reaction, it produces current electricity. So basically, chemical energy is converted to electrical energy. Why? During reaction, chemical energy is there. That chemical energy is converted to electrical energy. Clear? Right there. A electrochemical cell, a electrochemical cell, a electrochemical cell produces current electricity, produces current electricity, produces current electricity, produces current electricity by reactions taking place, by reactions taking place, by reactions taking place, by reactions taking place. Right. Observe. Observe very carefully. There you look here. Observe. General cell diagram of an electrochemical cell. Look very carefully. There you go. You should have a beaker. You should have a beaker. What is filled inside the beaker? You call it a electrolyte. What is it called as? Electrolyte. There you go. Electrolyte. In our syllabus, always the electrolyte is aqueous H2SO4. What is the electrolyte in electrochemical cell? In our syllabus, aqueous H2SO4. Always in our syllabus, H2SO4 aqueous. Always H2SO4 aqueous. Lamai, tell me, H2SO4 aqueous, strong acid or a weak acid? Strong acids always liberate ions, H plus ions, by complete ionization or partial ionization. That means H2SO4 will always liberate H plus. Then what will automatically get liberated? SO4 2 minus. So in a H2SO4 aqueous solution, do you find H2SO4? Do you find H plus and SO4 2 minus? H plus and SO4 2 minus. Why? It ionizes. If you take H2SO4 solution, you will never find H2SO4. Instead, what you will be finding? H plus, by it has liberated H plus, and automatically SO4 2 minus. You can never find H2SO4. Clear? So in this solution, what are the ions present? H plus. More important. Now. So when you are drawing an electrochemical cell, what's the first second thing to be considered? You should write the ions present in the solution. That's the second thing. Clear? Next one. There you go. Electrolyte is filled. Next, you keep your two metals inside that. You keep your two metals inside that. This is going to be metal M1. I will take it just a general diagram. No? This is going to be metal M2. M1, M2. You all tell me. M1 and M2. If M1 is more reactive and M2 is less reactive, out of M1 and M2, who will undergo oxidation? Why? It is more reactive. Who will undergo reduction? M1 will undergo oxidation, then M2 will undergo reduction. Here am I. Together with M2, there is H plus ions also. Later you will understand that actually it is not M2 undergoing reduction, it is going to be H plus undergoing reduction. Later you will understand. But however, the place where they undergo reduction is called as what? Cathode. That is guaranteed M2. So your cathode is going to be M2. Then what is going to be the anode? M1. Always. Always. Now tell me, what does the electrochemical cell do? Produces electric current. So once I connect a wire here and put a bulb, what will happen to the bulb? Bulb will light up. If I put a galvanometer, what will galvanometer do? It will give a deflection. Clear? Understood. This is the general diagram for any electrochemical cell. What are the electrochemical cells we have in our syllabus? We have zinc copper electrochemical cell and zinc iron electrochemical cell. Last one, iron copper electrochemical cell. Only three. Once when you study those three, electrochemical cell is over. Clear? Understood? Write down electrochemical cell. Write down electrochemical cell. What wrote, no? It produces me. Write the general diagram. Write the general diagram. Write the general diagram. General diagram. You can get it in the input. Write the general diagram. Under that, draw the general diagram. Under that, draw the general diagram. General diagram. General diagram. Draw the general diagram. Quick. Just mention down. M1 is more reactive than M2. 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 Keep in mind, I told you later you'll understand reduction actually not M2 taking place. Another person will take place. I'll tell it later. But however, it takes place at M2, therefore you call it cathode. It takes place at cathode. At M2, therefore you call it cathode. Right. Observe, huh? Only first one I will teach. You will automatically understand how to do the other reactions as well. You'll automatically understand how to write other reactions as well. Observe. There you go, zinc copper. First of all, what you do? You do a beaker. There you go, beaker. What is filled inside the beaker? Electrolyte. What's the electrolyte? Always I told you. H2SO4, what state? Lamai H2SO4 aqueous. What are the ions present? There you go. H plus ions are there. SO4 2 minus are there. So first of all, you write the ions present. Next, what are the two metals? Put the two metals. Please mark zinc, copper. Out of these two, who is more reactive? Who will undergo oxidation? There you go. Zinc will undergo oxidation. Then zinc should be the anode. Then guaranteed copper will be the next what? Using connecting wires, connect a bulb or a galvanometer, anything. Anything where you can detect some current. I'll connect a bulb. Now, what is going to take place? Now, I told you my current is going to be produced. So, you'll ask me, sir, how is current produced? Now, listen. No? Zinc is more reactive. Then zinc should undergo oxidation. Tell me the oxidation reaction of zinc. Zinc converting to by liberating to what does this mean? Zinc is there. Zinc is jumping into the solution as zinc 2 plus ion, leaving what? 2 electron. See, zinc is there. Zinc will jump into the solution as zinc 2 plus ion by leaving 2 electron. All the zinc atoms will do the same. Jump into the solution, zinc 2 plus, leaving 2 electron. Another zinc, jump into the solution, zinc 2 plus, leaving 2 electron. Now, what can you tell about the number of electrons in zinc and number of electrons in copper? Who has more electrons? Zinc. More electrons are there means negative terminal or positive terminal. Then what is your negative terminal? Then what is your positive terminal? Lamai, you all tell me. Negative terminal is there, positive terminal is there. What will electrons do? It will go from negative terminal to positive terminal. Then from here to there will be electron flow. Then opposite to that, what will be flowing? Current will flow. Current will flow. Now you might ask me, sir, what happens to the electrons that come here? Now slowly electrons are moving down. What happens to the electron that comes here? Lamai, electrons are coming here. Who likes electron? Positive ions. Then what will the positive ions in the solution do? Go near that to take that electron. Lamai, what are the positive ions in the solution now? H plus and zinc 2 plus. Both of them will go there. Both of them will go there. Tell me, can both of them gain electron? Gain electron is what? Reduction. Can both of them undergo reduction? Out of these two, who will undergo reduction? What is the reduction reaction of H plus? 2H plus 2 electron H2. What is this reaction? Oxidation. You can write just oxidation reaction. Oxidation reaction. Another name, anodic reaction. What is this reaction? Reduction reaction. Another name, there you go. Cathodic reaction. This is your first reaction. This is your second reaction. Clear? Understood? Shall I tell you the shortcut method? All the electrochemical cells, reduction is this. All the three, reduction is this. So should you think about these concepts? No. You find which one is more reactive, that will undergo oxidation. Reduction is always what? H plus. Both the reactions for any electrochemical cell you can write. Clear? Understood? Then you all tell me. If I have zinc and, this is zinc and copper, no? Zinc and iron, who will undergo oxidation? What's the oxidation reaction? Reduction is what? Always. Iron and copper. Who is more reactive? Who will undergo oxidation? What's the oxidation reaction? Reduction is always all the three electrochemical cells done. That's all. So when you get to your exam, what are the things they will ask you? They might ask you to draw the electrochemical cell. So should we draw these electrons, zinc 2 plus jumping, those things you don't need to do. You need to draw the beaker plus electrolyte, but What is the electrolyte? You need to mention that. Plus the two electrodes, zinc and copper. Which is anode, which is cathode, you should mention. Anode is negative, cathode is positive, you should mention. Electron flow direction, current flow direction. That's all. Full marks is there for electrochemical cell. Question number 9, A part. You have full marks. If you get electrochemical cell, guaranteed you are lucky. If you get electrolysis, you are more lucky. Yeah. Understood? Do for this, you are going to try for the next one. No? So these things you don't actually need to mention. I mentioned it so that it's easy for me to explain. I'll erase it and keep. Question work. Write there zinc and copper, and do this. And reactions, of course, you can write by your own. Do. You're okay. Finish. Again, zinc and copper. Who is more reactive? Then who will undergo oxidation? Then near whom electron density will be high? The negative terminal is opposite of copper. Zinc will undergo oxidation, jump in a solution forming zinc 2 plus ion. What's the reaction? Zinc converting to zinc 2 plus by leaving 2 electron. Did you write it? Those who don't write down. Next, what are the positive ions in the solution? Zinc 2 plus and H plus. Who will undergo reduction? What's the reduction reaction? That's all. Write the reactions. Those who finish, go to the next one. Those who finish, go to the next one. Go to the next one. Before starting, tell me. Zinc and iron. Zinc and iron. How do you do the electrochemical cell? Beaker is there. What's the electrolyte? Initially, what are the ions in the solution? H plus, SO4, 2 minus. What are the metals? Zinc and iron. Who is more reactive? Then zinc is going to be your. That means zinc will jump in a solution forming, leaving 2 electron. The near zinc electron density will be, then the negative terminal is, opposite is for the iron. Then iron is going to be your, what's the charge? Next what? Current flow direction, electron flow direction. Negative to positive, there will be the electron flow. Positive to negative, there will be a. What is your job now? Write down the reactions. Oxidation half reaction. And reduction half reaction. Your job. Always tell me reduction is what? 2H plus 2 electron, 2 electron, hydrogen. After finishing that, go to the next one. Next is iron and copper. Tell me, what's our oxidation reaction? What's the oxidation? Zinc converting to, by liberating to, what's our reduction reaction? Plus converting to, last warning for you three. Next time get out, huh? Yes, so many are messaging me in the morning asking for seats. 2, 3 coming here in front end. Morning also I got so many messages for the seats. Mere own nothing, you know. Finish. Next one. Next one. Iron copper. Iron copper. You all do. You all do. Iron copper. There go bigger. What is filled inside? What are the ions? What are the metals? Iron and copper. Who is more reactive? Then what is going to be the anode? Copper. Now one shot tell me. At anode oxidation take place, iron will jump into solution as Fe2 plus. Then what is remaining in the electrode? Electrons. The negative terminal is positive terminal is the connecting wire. Which side you have the electron flow? Iron to copper. Then the current flow. What is the oxidation reaction? Fe coming into Fe2 plus 2 electron. That is your oxidation reaction. What is the reduction reaction? Still we are not completed. Actually, most of the things are completed in electrochemical cell. One more thing to be added, writing the physical state. I always remember shortcut method is whenever when you have an ion and if there is water in the medium, H2SO for aqueous, no? If there is water in the medium and if there is ion is going to be aqueous state. What state? Aqueous state. All the other things you all know. No? All the other things you all know. So coming into the first one, zinc 2 plus aqueous medium. Then what's your state? Aqueous. Zinc, what's the state? Sorry. H plus What is there? What's the medium? Aqueous medium. H2 is a next one. Zinc, what's the state? Zinc 2 plus, what is there? H plus, H2, Fe, iron is there, aqueous medium. H plus, H2. Right. So the confusing part is whether this is a liquid, solid, or aqueous. No. So remember, iron is there. Water is there, aqueous medium. If there is no water, it will be in liquid state or solid state. Only one place you will be encountering that. That also I'll tell you. Right. Finish. Okay. Right. All these three cells now as a summary. Shh. Diagonal cell. Cell diagram. Observe. This is the most important part. This is what you should check the day before the exam. Next, oxidation reaction. Next, reduction reaction. Next, anode. Last, cathode. Don't try listen. You are going to work by your own. Don't try listen. What is our first cell? Zinc and copper. There you go. First cell, zinc, copper. Observe. Huh? First of all, we write the anode and cathode. Zinc, copper. Who is more reactive? What is the anode? Then what is the cathode? You know the anode. You know the cathode. We'll draw the cell diagram. Always there you go, beaker is there. What is filled inside the beaker? What medium? What are the electrodes? There you go, zinc. There you go, copper. You connect it through the external circuit. Zinc is going to be your, I'll mark it capital A. Copper is going to be your, I'll mark it capital C. At anode, zinc will jump in a solution forming zinc 2 plus by leaving 2 electron. Then zinc is going to be negative or positive. It's the negative terminal. Then copper is going to be that where you have the electron flow, that where you have the current flow. What's the oxidation reaction? Zinc 2 plus. What are the states? Zinc 2 plus. In all the reactions, what is the reduction reaction? What's the state? Here. There you go. First reaction. Clear? Write it first. Better to take a full page because we'll be going down. Like this, 3 cells are there to come. So better take a full page and write. Manage the space, huh? Anode and cathode shorter. You write it in a shorter space. Reduction also you can write it in a shorter space. Oxidation and cell diagram makes a little bit larger space. Work. After finishing, give a try to the next one. Zinc ion. Next one, zinc ion. Give a try. So before the exam, that is what you are going to see. Before the exam, that is what you are going to see. Not the full syllabus. There second one, zinc and iron. First we will write the, where's the anode cathode part? This part. First we will write the anode cathode. Zinc and iron. What is going to be the anode? Zinc. Cathode, iron. Then who is going to undergo oxidation? Zinc. Who is going to undergo reduction? Iron maybe. Reduction who? H plus, that reaction. Now we will draw the cell diagram. There you cell diagram. First the beaker. What is filled inside? H2SO4. What state? What are the metals? What are the metals? Zinc and iron. There you connected externally. Zinc, iron. Tell me, zinc and iron. Who is going to undergo oxidation? Then who is going to be the anode? A there. Then cathode is guaranteed. Negative terminal is zinc, minus there. Positive terminal is, there you go. Electron flow where to where? Current flow. Now what? Oxidation reaction. Who is going to undergo oxidation? Then what's the reaction? Zinc converting to zinc 2 plus by liberating state. Zinc 2 plus. There you go. Second one also over. Go to the last one now. Go to the last one. Always reduction is same. Huh? Always reduction is same. Last, what's the cell? Iron and copper. Yeah, work. Work. Finish. Iron and copper. Tell me. Iron and copper. Shh. Where do we write anode and cathode? Here. Tell me iron and copper. Anode, Fe. Cathode, cell diagram. There you go, beaker. What is filled inside the beaker? Let me tell it with the state, H2SO4. What are the electrodes? Iron and copper. There you go, iron. Next one is, who is more reactive? Who will undergo oxidation? Who is the anode? A. Then cathode is going to be, what is going to be the negative terminal? Positive terminal. connect the wire. Which direction electron flow? Current flow. What's the oxidation reaction? Fe2 plus reduction reaction. Shall I write it here and keep again? 2H plus 2 electrons converting to H2. Ramai, we didn't write the state. Fe, what's the state? Fe2 plus. Here also. H plus, what's the state? Yeah. We will write for the previous one. Previous one, right? Right. All finished. There you go. Electrochemical cell in one diagram. So the day before you go for your final exam, under electrochemistry, what you are going to see? Only this. Full shortcut is here. Some as a summary note. Clear? Now tell me, electrochemical cell. What do you feel? Letter by letter. Letter by letter. Letter by letter. There you go. Letter by letter. Start. P next. A next. P next. P next. A. There you go. Next. Next. E next. 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 There you go. Don't forget D. Okay. Lamai, me. Those who didn't fill the Google form, some of you message me, you know. Those who didn't fill the Google form, please raise the hand. By Windows, just raise the hand. Just raise the hand. Only those who didn't fill the Google form. Other shape එක සද්ද දාන්න නැතුව කතා කරන්න කවන්න. One part ඕන. සද්ද නැතුව කතා කරන්න. Raise the hand, raise the hand, raise the hand and those who didn't fill the Google form. Those who didn't fill the Google form, raise the hand. Me හොඳට raise the hand. Raise the hand, raise the hand. Check. Right, online am I right? Electrolysis, why don't I do electrolysis? Lama, in electrochemical cell, what you do? You perform a reaction, from that you produce electric current. Electrolysis is the opposite of it. That means you send electric current and perform a reaction. It's the opposite. There you do a reaction, produce electric current. Here you send current and do a reaction. Lama, to send current, guaranteed you should have an electricity source. Usually we use a battery. So if you see a battery, electrochemical cell, electrolytic cell, electrolysis. Right. What is the general cell diagram? Observe. Huh? What's the general cell diagram? Guaranteed you should have a beaker. There you go. What you fill inside the beaker? Electrolyte. You might tell me H2SO4. No. Here there are varieties of electrolytes. I will tell them. However, what you fill inside is electrolyte. There you go. Electrolyte. Electrolysis means here you don't use two different metals. There you use zinc, copper, iron, like the different metals. No? Here you don't use different metals. You use carbon rods. Or if you are rich enough, platinum rod. So what you use? Carbon rod or platinum rod. Something inert. Like carbon rod is carbon graphite. Will it react with someone? No. It's actually non-metal. Platinum, low end activity series. Will it react? No. Some sort of a inert material should be used as an electrode. There you go. Electrodes are going to be carbon graphite. Or if you are rich enough, yes, platinum. Platinum can be used. Any electrode can be used. But in our, you all know in Sri Lanka, carbon electrode, not platinum. In our syllabus, we talk about carbon electrode. Now, tell me, here guaranteed you should supply electric current. That means you should connect this to a battery, positive and negative. In this one, you can easily find the positive and negative terminal. How? Electrode connected to the positive terminal is your positive electrode. Then electrode connected to the negative terminal is going to be the negative electrode. Up to there, clear? First draw this. And electrolysis. First we'll write a point right there. In electrolysis, a reaction is triggered. Bypassing electricity through the electrolyte. Draw this little bit bigger. I'll be slowly adding one by one some more elements. Anode, cathode, I'll be adding. It's so many things are there to be added. So draw it a little bit bigger. All finished? Right. There are some important concepts that you should know to write anything in electrolysis process. Concept number one about electrolyte. Look at the board. Concept number one about electrolyte. About electrolyte. So, what solution can be used as electrolyte? There are four types of solutions that can be used as electrolyte. But whatever you use, it should have mobile ions. So what is mobile ions? Ions with mobile phone. Never. Ions that can move from one place to another. Then tell me, solid state substance, even if it has ions, can it move? Then guaranteed your solution should be in liquid state or aqueous state. One of that state. What are the four types of electrolytes? First one. There you go. Aqueous solution of ionic compound. Observe very carefully. Aqueous solution of ionic compounds. That means sodium chloride aqueous. Sodium chloride aqueous, what will happen? Sodium plus ion, Cl minus ion will be there. Some more ions are there, I will tell it later. However, sodium plus ion, Cl minus ion is there. It's an ionic compound in aqueous solution. Guaranteed it has mobile ions. Can it conduct electricity? Yes. Can it be used as electrolyte? Yes. Second one. Molten or fused ionic compound. Molten or fused ionic compound. That means you take sodium chloride solid. You heat it very well until the melting point. Then what will you get? Sodium chloride liquid. Will it have water in it? No. But however, you have ionic compound in a liquid state. Then it has mobile ions or not? It has. There you go. Sodium chloride liquid. Next one. Third one. You can use acids in aqueous medium. For example, we used already H2SO for aqueous. Next, of course, bases in aqueous medium. What's the example? Sodium hydroxide aqueous. Clear? Understood? So any of these things can be used as your electrolyte. That's the concept number one. Clear? Let's write down under that. Concepts required. Concepts required. Finish. Right. Concept number two. Concept number two. Now you already know in this electrolyte you have mobile ions. That means guaranteed you have positive ions and negative ions. Now look, positive ions are there. You have a negative terminal, then positive ions will go towards the negative terminal. Lama, in case if there are several positive ions, all of them will go towards the negative terminal. No problem. However, whatever the number of positive ions are there, all of them will go towards the negative terminal. Now, at negative terminal, what are they trying to do? These are positive ions. They need electron. So at negative terminal, they will gain electron. Gaining of electron, oxidation or reduction? Reduction. So at negative terminal, what is going to take place? Reduction will take place. Reduction will take place. Huh? It is not going to undergo reduction. Reduction will take place. The place where reduction take place, you call it what? Cathode. There you go. Now can you see the difference? Check your summary note and tell me. In electrochemical cell, cathode is positive or negative? Here. So if you memorize one and keep, let's take for electrochemical cell, you memorize and keep opposite of it here. Clear? There anode is negative. Here cathode is negative. Clear? Right. Positive ions are going to go there, going to undergo reduction. In case if there are several positive ions, will everyone undergo reduction? Only one person will undergo reduction. Who is that? The ion which is lower in the activity series. That is also there. You all told me about the negative ions. Where will it go? It will go here. It has negative charge, means it has excess electron. Then it will liberate electron. Liberating electron, oxidation or reduction? Oxidation takes place where? Anode. Then positive terminal is your anode. It takes place at here, therefore I write oxidation. It takes place there. Huh? It takes place there, therefore it's the anode. In case if there are several negative ions, who will undergo oxidation? Who will undergo oxidation? The ion which is above in the activity series. Clear? Understood? At this data also, I'll give a note on that. Quick. Right, another write down. Another write down. Did we write this concept? We wrote this concept now already. Did you all name it number 1? Now number 2. Number 2. Pero Finish. Now write down concept number 2. Concept number 2. Number 2. Concept number 2, right there. Positive ions in the solution. 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 Positive ions in the solution will migrate to negative terminal. 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 And undergo reduction. And undergo reduction. And undergo reduction. And undergo reduction. Next point. Negative ions in the solution. Negative ions in the solution. Negative ions in the solution will migrate to positive terminal. Will migrate to positive terminal. Will migrate to positive terminal. And undergo oxidation. And undergo oxidation. And undergo oxidation. And undergo oxidation. Under that, take a color pen, put a star and write. Color pen, put a star and write. Only the metal located. Only the metal located. Only the metal located. Only the metal located higher in the activity series. Higher in the activity series. Higher in the activity series will undergo oxidation. Will undergo oxidation. Will undergo oxidation. And the metal located lower in the activity series. And the metal located lower in the activity series. And the metal located lower in the activity series. Activity series will undergo reduction. Will undergo reduction. Will undergo reduction. Will undergo reduction. Clear? 3 more special points. We can start electrolysis. 3 more special points. There you go, special points. Now, usually negative ions will undergo oxidation or reduction. Negative ions will undergo oxidation. In case if you have sulfate ion in the solution, it will never undergo oxidation. If you have sulfate ion in the solution, it will never undergo oxidation. Special point number 1. Now, special point number 2. Observe. This is number 1. Special point number 1. Now, number 2. If you have OH minus sign, if you have OH minus sign, how will it undergo oxidation? That reaction you should memorize and keep. Oxidation reaction of OH minus sign. Now, my 4 OH minus ion convert to 1 oxygen 2 water and 4 electron. What? 4 OH minus convert to. So here it goes 1, 2, 4. 4 OH minus convert to. Again. OH minus convert to. OH minus signs. Most of the time it is there in aqueous medium. So the state is what? Aqueous. Oxygen is. Water is guaranteed liquid. Huh? You can't tell water in water is aqueous. No, water is always liquid. Okay. Concept number 3. In case if you have Cl minus sign and OH minus sign in the solution, out of these two, Cl minus will undergo oxidation, OH minus will not undergo oxidation. If there is Cl minus and OH minus, who will undergo oxidation? OH minus won't undergo oxidation. If there is no Cl minus, OH minus will undergo oxidation. Clear? What are the first 3 special points? Sulfate ions, will it ever undergo oxidation? OH minus signs, tell me the oxidation reaction. If there is OH minus and Cl minus, who will undergo oxidation? Clear? Write their special points. Special points. SO4 2 minus sign, sulfate ion. SO4 2 minus sign. SO4 2 minus ion. Sulfate ion. SO4 2 minus ion. Will never undergo oxidation. Will never undergo oxidation. Will never undergo oxidation. Will never undergo oxidation. Second point. OH minus oxidation reaction. OH minus oxidation reaction. OH minus oxidation reaction. Before writing again, tell me. Write down. Mention the states also. Last one. If there is Cl minus and OH minus in the solution, if there is Cl minus and OH minus in the solution, if there is Cl minus and OH minus in the solution, tell me who will undergo oxidation? Cl minus will undergo oxidation. 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 Clear? One more special point. One more special point. Fourth one. If your electrolyte is an aqueous solution, we had electrolyte in aqueous solutions also, no? Aqueous solution of ionic compound. Acids in aqueous medium. Bases in aqueous medium. So those three had aqueous medium. Aqueous medium means together with the compound, what else is there? What is there? If there is ionic compound acid or base in aqueous medium, together with the compound, the water molecules will also dissociate into their ions. That means water will dissociate into H plus OH minus. Why H plus OH minus? See, water molecule is 1 oxygen, 2 hydrogen. If this is present together with the ionic compound, that ionic compound and them, it will make this bond breaks. When this bond breaks, what is there? H plus. What else is there? OH minus. So if there is aqueous medium electrolyte together with the ions already present, what else is additionally there? H plus, OH minus. Always it is there. That means, see, this solution, what are the ions? Guaranteed Na plus, Cl minus, aqueous medium means H plus, OH minus. Here do we have? Why? No water. Then what are the only ions? Here, acids in aqueous medium. H plus is there from the acid. SO4 2 minus is there from the acid. Plus OH minus is there. Here, base in aqueous medium. Na plus, OH minus together with that H plus, OH minus. Clear? Understood? Try the last special point. In aqueous medium electrolyte, in aqueous medium electrolyte, together with the compound, water will also undergo ionization. Water will also undergo ionization. Back row, write down. Water will also undergo ionization. Write this. Finish. Right, now we can start electrolysis process. First one is electrolysis of molten NaCl. What? Electrolysis of molten NaCl. That means sodium chloride in liquid medium. That means you take sodium chloride, heat it, and make a liquid from it. How do you do the electrolysis process? See, you can take a beaker, there you go. What is our electrolyte now? What's our electrolyte? NaCl liquid. Then what are the ions in the solution? Na plus Cl minus. Do we have H plus OH minus? No. What is our electrode? Both are going to be carbon electrode. No two metals. Both are carbon electrodes. Electrodes are connected to the battery, positive and negative. Electrode connected to the positive terminal is going to be your. Electrode connected to the negative terminal is your. Now what? We'll find which ion goes to which place. Sodium plus ion goes to. Only one ion is there, no? Then who will undergo the reduction process? Na plus will undergo reduction. What's the reaction for Na plus? Na plus will gain an electron, convert to Na. Na plus, is there water in it? Then what's the state? Liquid. Sodium is of course liquid. Now this reaction is reduction or oxidation? Reduction takes place at, then which is your cathode? Negative terminal. Opposite is the other one. This is your anode. Now tell me, out of Na plus Cl minus, we will go to the positive terminal. We will undergo oxidation. What's the oxidation reaction? 2Cl minus will convert to Cl2 gas by liberating 2 electrons. This is what reaction? What is the state here? Aqueous. What's the state? Here. There you go. Finish. Clear? Right on. Electrolysis of molten sodium chloride. 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 Will all the water dissociate? No. Not all the water will dissociate. You call it actually partial dissociation and it comes to equilibrium. It finally reaches equilibrium. Actual symbol is not this. You need to put symbol like this. This is the actual symbol. H plus is also there, OH minus is also there, O2 is there. This is the actual symbol. But however, in the book they are given with the normal symbol, therefore I gave it. If you want, just write it there. It undergoes partial dissociation. It undergoes partial dissociation. Finish with this. Finish. Under this lemma, there's a very special point. Shh, shh, shh. By doing this, what you can produce? You can produce sodium. Also, you can produce chlorine gas. So this is the method that is used to extract sodium metal, and as a byproduct, chlorine gas will be released. This is industrially done, and for that you use a special cell system. That cell is called as Downs cell. What is that? Downs cell. Actually speaking, this can't be done in a week. Why? Make sodium chloride to a liquid. You should heat it to 800 plus 800 degrees Celsius plus. Tell me a beaker. You keep it to 800 degrees Celsius. What will happen? It will also melt off. So basically, you can't actually do it in a beaker. You do it in a down cell. Okay. Another write down. This method is used. This method is used. This method is used. This method is used to produce sodium Na. To produce sodium. To produce sodium industrially. 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 To produce sodium industrially. Industrially. Go dash and write down cell. Down cell. Down cell. Down cell. Dash and write down cell. Right. Second one. Electrolysis of aqueous sodium chloride. NaCl aqueous. You all start drawing the cell diagram. Right. What is your cell going to be? Daivu, beaker. What is the electrolyte? Sodium chloride aqueous. Sodium chloride aqueous. What are the ions? What else? Aqueous medium. Electrodes are there. Carbon electrode. Positive terminal, negative terminal. Electrode connected to the positive terminal is your. Electrode connected to a negative terminal is your. Next what? Positive ions will go towards the and undergo out of Na plus and H plus. Who will undergo reduction? H plus. Reduction. Reaction. There you go. H plus. What's the reaction? 2H plus plus 2 electron H2. States aqueous and then gas. H plus has gone there. What happens to sodium plus? No changes. It is there in the solution. Now what about the negative ions? Negative ions will migrate towards the. Out of these two, who will undergo oxidation? Cl minus. I told you OH minus is there, Cl minus there. Who will undergo oxidation? Cl minus. What is the reaction? 2Cl minus convert to Cl2 by liberating 2 electron. This is your oxidation. Oxidation takes place at anode. This is your anode. Reduction takes place at cathode. This is your cathode. Right. Now you can see H plus is converted to H2 gas, released out. Cl minus is converted to Cl2 gas. Cl minus is converted to Cl2 gas and released out. Then what is remaining in the solution? Na plus OH minus. Na plus OH minus. Na plus OH minus. Together NaOH. So during this cell process, what will be remaining at the last? NaOH. What is NaOH? Sodium hydroxide. This is the method to produce sodium hydroxide. Clear? You start it from sodium chloride. You end it with what? Sodium hydroxide. So sometime in the exam they might ask, what is the end product in electrolysis of sodium chloride? What's the end product? Sodium hydroxide. What are the gases evolving? Hydrogen gas and chlorine gas. Clear? We'll write a special point there at the end. The remaining Na plus and OH minus, the remaining Na plus and OH minus, the remaining Na plus and OH minus will produce NaOH, will produce NaOH, will produce NaOH, will produce NaOH. Right. Electrolysis process is done. We have 2 more electrolysis process and 1 electroplating. That's all. I told you corrosion of metal is not for today. Can you remember corrosion of metal? I did once in 1000 MCQ itself. The final experiment I explained. So corrosion of metal is not for today. Electrochemical cell, electrolysis and electroplating. Electrochemical cell fully over, electrolysis half over, another half is there, and then what we have finally? Electroplating is. Up to now, whatever you learned, is it clear? Now, most of you ask, sir, what about overall reaction? I didn't go to confuse you all about the overall reaction at the start itself. That's what has happened to all of you in the classes or the schools. No? At the beginning itself, they try to teach you overall reaction. From there, you start hating the electrochemistry lesson. Now, you already know the concepts. You know what is happening. Now we write overall reactions. See you. Overall reactions. Now, can you remember at the beginning I told, when writing oxidation half reaction and reduction half reaction the name is oxidation half reaction and the other one is reduction half reaction. That means are they full reactions? They are what? Half of a reaction. During oxidation, what is happening? Electrons are given. During reduction, what is happening? Electrons are taken. You all tell me, can you give something if there is no one to take? Can you take something if there is no one to give? That means giving and taking should be done simultaneously together. Then oxidation reaction and reduction reaction also proceed how? Simultaneously. If oxidation takes place, guaranteed what should take place? Reduction. During oxidation, electrons are given. During reduction, that given electron is taken. So it's a cyclic process. During oxidation, electrons given. During reduction, that electron is taken. Oxidation give electron, reduction take electron. That's why we call them half reactions. They are not full reaction. Half of a reaction, oxidation, another half of a reaction, reduction. Both together, the full reaction, you call it redox reaction. What's the name? Redox reaction. Redox reaction. This is the full reaction. During redox reaction, then what is happening? Reduction and oxidation. Both together you call redox reaction. Now, how to write redox reactions? Listen. First one. Now, look at your book and tell me our summary note about electrochemical cell. First electrochemical cell. What did we write? First electrochemical cell, zinc and copper. What was the oxidation reaction? Zinc 2 plus 2 electron converting to zinc solid. I'm not interested about the physical states now because we are learning redox reaction. This is the first reaction. Is this a full reaction? It's a half reaction. What's the second reaction? Second reduction reaction. 2H plus 2 electron. This is the second reaction. Is it a full reaction? This is half reaction. This is half reaction. When you add them, you have your full reaction. How to add? Only two things you should check. First thing, check whether the number of electrons are same. Like number of 2 electrons, did I make a mistake? Oxidation, I made a mistake. No? There you go. There you go. Zinc jumping into a solution. Zinc 2 plus by leaving 2 electron. This is giving electron. This is taking that electron. They are full reactions, the half reactions, the half reaction. To make them full reaction, what you should do? Add them. For adding, only two things you should do. First thing, check whether the number of electrons in oxidation and number of electrons in reductions are same. If they are same, directly add all the species in the reactant side and all the species in the product side. That means, tell me what are the species in the reactant side? Zinc is there, 2H plus, add it, 2H plus and 2 electron. And add all the species in the right hand side. What are species in right hand side? Lamai. Left hand side also 2 electron. Right hand side also 2 electron. What you can do? Then what is your final redox reaction? Two H plus converting to physical states are important. This is solid. This is aqueous. This is aqueous. This is now clear how to write full reactions. Write it. Write there redox reaction. Redox reaction. Redox reaction. Now can you see, now with a free mind, you can edit and do. Make arrasse them, you get confused. Okay? Redox reaction, write this. Oxidation and reduction. Add them and do. Add them and do. Sorry. Ion and copper, all right. Ion and copper, all right. What's the reaction? Third one. What's the reaction? Tell me. Fe converting to first reaction. Second one, always H. What's the redox? First check whether the electron numbers are same. If they are different, I'll teach later. First check whether the electron numbers are same. If they are same, what to do? Add them. 2H plus converting to what can you do about electrons? Same. Can't cancel them. What you have? States solid. Okay, clear. In this next step is there when electron numbers are different, and the other step is how to add the remaining reactants which are remaining, whatever the product or reactant which are remaining, how to add them. Only that part is there. Redox will be over. After that, two more electrolysis process is there. After that, electroplating. That's it we have. Now you can take a break. 45 minutes break. Come back sharp at 12:45. I'll be starting. Sharp at 12:45. I'll be starting. Washrooms are there behind. You can use. Right. Shh, shh, check. Right. Shh, shh. Right. We were doing some redox. We were doing some redox. In redox, what we do, 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 oxidation of reaction is there, reduction of reaction is there. Remember, we just add them. Before adding, what you look whether the number of electrons are same. If they are same, you can directly add lamai. In case if the number of electrons are not same, then what can you do? Look at this, will you? We didn't come across this kind of reaction, but we'll just write and see. Shh, shh. Oxidation is there. Sodium converting to sodium plus 1 ion by liberating an electron. First. Reduction. 2H plus gaining 2 electron. Up. H2 gas. Now what can you tell about the number of electrons in the oxidation and number of electrons in the reduction? Are they same? Then can you directly add them? Before adding it, what you should do, make the number of electrons same. You all tell me how to make the number of electrons same. Multiply the full first equation by 2. Let's multiply. Multiply by 2, then how many sodium? How many Na plus? How many electrons? I'll name it as equation star. That is also oxidation only. Now what you can do? Add star and 2. Let's start. There you go. Star. What is there? 2 sodium. Plus. Plus. Product side. What can you tell about the number of electrons? Cancel them. What's your final reaction? Product side. States. Now can you understand that adding part is not a hard thing. Once when you do about 2, 3, you can now understand. Clear? Let's write it right there. If the number of electrons are not equal, if the number of electrons are not equal, if the number of electrons are not equal, if the number of electrons are not equal. Who is that using the phone behind? If the number of electrons are not equal. Right there. Oxidation. No. We'll just write. We need to first balance the number of electrons. We need to first balance the number of electrons. We need to first balance the number of electrons before adding. Before adding. Before adding. Do. Shall we do one more just for fun? Just for fun, na? Oxidation. Hydroxide oxidation. Y'all tell me. 4OH minus. 4 electrons. 4 electrons. First reaction. Second one. Reduction. 2H plus gaining 2 electron hydrogen gas. You all write the redox. Tell me, is the number of electrons same? Then balance the number of electrons and write the redox. Just for fun, don't take it much serious. You can write the states and do me. Yeah, I'm not interested about states. First, balance it. Later, you can indicate the states. Finish. Which equation you all multiplied? First or second? Multiplied by? Second equation you multiply by 2. How many H plus? How many electrons? How many hydrogen gas? I'll name it as equation star. Now what? Add the right hand side and left hand side. Right hand side, what you have? 4H minus plus 4H plus 4 electrons. This side, 1 oxygen, 2 water. How many electrons? Now what? 4 electrons. 4 electrons cancel out. What here finally? We did it just for one. Shall we take it one more step ahead? See? H plus OH minus. H plus OH minus. What is that? 4H plus 4OH minus. 4H plus 4OH minus. How many water? Left hand side, then what you have actually? 4 water. Right hand side. 1 oxygen. 2 water. 2 hydrogen. Can we go one more step? Can you see something? What you all see? Both the sides, what is there? Here 2 water, here 4 water. What you can do? Cancel out 2 water. No? Then what is remaining? 2 water in the left hand side. Right hand side. 1 oxygen, 2 hydrogen. Can you see? After that, it is all maths. It's all maths. You can do it. In maths also, we do the same. Only difference is, instead of the arrow symbol, you have an equal symbol in maths. Mention the states: water, liquid, here gas, here gas. Actually, for each and every step, you should mention the state. But here I'm not interested about that because states I separately taught you all. Now the people who asked balancing in a way addition. Now clear, everything clear? Everything clear? Any doubts? That's all. Now back again to the electrolysis process. What are the two electrolysis we did? Sodium chloride liquid, sodium chloride aqueous. That's it we did. Third one, electrolysis of NaCl aqueous. Sorry, copper sulfate aqueous. We did NaCl, copper sulfate aqueous. Copper sulfate aqueous. Copper sulfate aqueous. Give a try to draw the electrolytic cell. Tell me before doing. What is our electrolyte? Tell me, what's our electrolyte? Copper sulfate aqueous. Then what are the initial ions in the solution? SO4. H plus. Both the electrodes are carbon electrode connected to positive and negative, and draw the electrolytic cell first. Draw. Work. I repeatedly tell this every place. Me boys generation me වැඩ කරන්න ඕනි. You can see girls are all working. They are more working. හරිද? I කට්ට කාගෙන කනවා. Boys only 1 or 2 are working. That means what? All the high ranks in our generation will be occupied by whom? These people. What we have to do? When they tell to scrap some coconut, we'll have to do. When they tell to cook, we need to cook. We can't tell anything. Why? They will learn more than us. Already it has started happening. You check any class, majority is whom? Girls. Usually who takes the majority? Boys, no? Girls. You go to A-level bio section. Bio is, however, mostly girls select. They are 90% girls. Bio, okay. Take math section A-level. 3/4 of the class is girls. I think boys are in art section. No, don't laugh. That is also a good one. Finally, you can become a politician. That's why still in our country, the leading politicians are boys, even though they are acting like girls. After A-level, go to faculties. Medical faculty, however, that is girls. Okay, no problem. Okay, that is for you all. Keep it till you. Engineering faculty. A place where you can rarely see a girl. Boys refuse to go. Now, majority is girls. Now, some are showing the teeth also. At least I should get into engineering faculty. Medical faculty, almost full is whom? Girls. That means what? Even if we have some itching problem, we need to open and show to them. We will not have specialist in boy, specialist in those. Now, it's not funny. It's not funny. It's a huge issue. If this continues, lamai, boys, being under girls is no problem. But still, itching problem showing. And the most boys now, your idea is, I know, after level, take the license, buy a 3-wheel, drive Uber. Lamai, don't come to that mindset. Try somehow to catch them. Not to catch them that you all think. In terms of education, go up. You go behind them. You go behind. Finally, you will become a medical engineer, medical doctor. We are Uber driver. Hey, tell anything, no? In the at least for that, boys start working. Start working. Start working for sure. Right? Boys usually all have fun. Yes, I know. Having fun is okay, but with that, what you should do? You should somehow go to a good position. Otherwise, now I'm also scared. Our generation will have to be under them for sure. Will have to be under them for sure. Not the normal thing. Now you all know. Until now, they were under us. No, whatever the things that we did to them, we will get it in opposite. Huh? We will get it in opposite for sure. Our generation. For the girls, of course, don't leave the boys to catch. Don't leave it. What you all are doing is superb. Keep doing it. Don't give them the chance. In the education, if you're on top, that means respect, protection, security, all those things will automatically come. So keep up that spirit. That's good. Okay. Boys, then depa. Then depa. Atarin depa. So that firstly the O-levels will be, after the O-levels there will be analytic, this thing provided no analysis of who got the majority results, what rank, there will be a gazette like thing released. We'll see this batch, is it girls or boys? And open challenge to the boys. Huh? Open challenge to the boys. In case if girls take the lead this time, that means with us, those who are studying with us will be on top of us. We'll have to continue our work in a low class level. Boys, girls will have to go up. So we'll see the results this time. Girls are in the don't give up. Okay. Right. Electrolysis of copper. I told this because when I wrote this, no boy started to write anything. Girls have already finished it. That's why it came into my mind. Hurry. Electrolysis of copper sulfate. Good. Girls don't answer now, boys. Huh? Show the spirit. Huh? Me, I am also boy. Boys, huh? Girls keep quiet. Girls keep quiet. Electrolysis of copper sulfate. What you should have already first beaker. What is the electrolyte? What's the electrolyte? Appa. There you go. Copper sulfate aqueous. What are the ions in the solution? Cu. Cu neve adi nivaraya. Cu CO2 plus and SO4 2 minus. Is that all, boys? No. What else is there? Appa. H plus and OH minus. Electrodes are going to be two different metals, ne? Electrodes are going to be two different metals, ne? No, sure. I think zinc and copper we use, isn't it? No. Then what we use? Carbon rods. Connected to a bulb, no? Battery. You all keep quiet, eh? Right, battery. This terminal is negative terminal, eh? Happa. This terminal, negative. Now the serious thing, huh? Negative terminal, anode cathode. We'll see who answers, boys. You all can enter engineering faculty for sure. Then this one, anode. Now tell you. At cathode, oxidation or reduction? Anode. Now the reactions, huh? Now the reactions. You all tell me. Now Mara question. Huh? Will both these positive ions go to negative terminal? Go to negative terminal, I'm asking. Oh, girls are also other one. Will both them go to negative terminal? I know your technique. When girls tell yes, you tell no. When girls tell no, you tell yes. I know. Aim and Adamite. Both of them will go to negative terminal. Why? Both of them are pursuing each other. They will go. But only one person will get selected. Correct? No? Millions will go. One person will get selected. That's how you all were born. No double meaning. Hurry. Out of these two, who will undergo reduction? Cu2, Cu. Who will undergo reduction? Why Cu2 plus H plus? It can't. Cu2 handsome. H plus Uber driver. Who will get the chance? Cu2 plus. There you go. Reduction. Reduction reaction. I'm not telling wrong for the Uber people. That's not the case. But I'm telling boys, those who have that as the ambition, change the ambition. Change the ambition. Change the ambition. That also we need. Do something in a different way. Right? Uber competition, you start some other company. Right? That is what you need. Uber people, if anyone watch finish. I need to go home today. Reduction. Who will undergo reduction? Copper 2 plus H plus. Cu2 plus gain 2 electron convert to boys. Cu2 plus, what's the state? Aqueous. Copper? Oh, you know, tell you. Copper. Sure. No. Correct. Copper. Harry. This is your reduction reaction. Sulfate is there, OH minus is there. Will both of them go to positive terminal? Yes. Tell me now, will sulfate undergo oxidation? No. Then who will undergo oxidation? Boys, huh? Boys. Tell me the oxidation of OH minus. Now tell you. Tell. Sorry, the fourth time. What? After that. 4OH minus convert to O2. Next, 2H2O. How many electrons? What are states? OH minus, oxygen, water. That's all. Copper sulfate aqueous, electrolysis done. Clear? Without looking, write down anything. Without looking, write down. Without looking, write down. No, yours stay behind. Come on, boo. And I'll take a screenshot. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Boys, ready? Question work. Finish. Now check whether your is correct. Now I'll tell something. You need to continue that. You need to try to continue and make the theory. We'll see girls or boys who makes the theory finalized. See. Copper 2 plus, the color is blue color. What's the color of copper 2 plus? Blue color. You all tell me what is going to happen during the cell process. What reduces? Copper 2 plus color is blue color. If copper 2 plus convert to copper, what happens to the blue back row? Back row. Hey, sit. Copper 2 plus color is what? Blue color. It converts to copper. Then what happens to the blue color intensity? Reduces. Copper, what's the color? Brown color. Brownish, red brown again color. So during the cell process, what you will be observing? Red brown color powder deposits or precipitates. So what can you tell about the observations during this reaction? Blue color intensity of the solution reduces 1. Reddish brown color powder, what is that? Copper deposits down. But gas evolves at anode. Oxygen. So what are 3 observations? Blue color intensity reduces. Reddish brown color powder deposits. Next, oxygen gas evolves. Okay. Write down. Right there. Observations. Observations. Observation. Observation. Another write down. Blue color intensity. Blue color intensity. Blue color intensity of the solution reduces. 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 Second one. Second one. Second one. Red brown copper powder. Red brown copper powder. Red brown copper powder. Red brown copper powder deposits at the bottom. 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 Third one. Third one. Third one. Oxygen gas evolves. Oxygen gas evolves. Oxygen gas evolves at anode. Right. So what happens? Blue color intensity reduces. Red brown color copper powder deposits. Oxygen evolves at anode. Oxygen evolves at anode. Okay. Right. Last one. Last electrolysis process. Last electrolysis process. There electrolysis of acidulated water. Electrolysis of acidulated water. That is your fourth process. That is your fourth process. Right. Electrolysis of acidulated water. What you basically do here? What you basically do here? What you basically do here? You are going to electrolyze water. What you are going to electrolyze? Water. But the issue is water doesn't have enough mobile ions. Sir, water can dissociate, no? Yes. Water can dissociate. See, water can dissociate, no? Yes. It can form H plus and OH minus, no? Yes, Lamai. But actually, this dissociation is a partial dissociation. Can you remember? I told you it's not full dissociation. It is what? Partial. So, will it have enough H plus and OH minus to conduct electricity? No. It won't have enough H plus and OH minus. If you wanted to make enough H plus and OH minus, what you need to do is add some acid to it. Once when you add some acid to it, forward reaction will be favored and it will produce more H plus and OH minus. So basically, to electrolyze water, what you need to add a little bit, some acid. Here we are going to add H2SO4. What does it? H2SO4. What does it is added? H2SO4. Tell me, we are adding H2SO4. Does that mean you are electrolyzing H2SO4? No. What you are electrolyzing? Water. Just to increase the mobile ions, you add that acid. Clear? Write a point there. Write a point. In electrolysis of water, in electrolysis of water, as water doesn't have enough H plus and OH minus, enough H plus and OH minus, you need to acidify it. For this, we add some H2SO4. So basically, you write it as H2SO4 aqueous, correct? No? H2SO4 with water. Water is highest. You call it H2SO4 aqueous. So what is the electrolyte here? H2SO4 aqueous. Clear? Understood? Now, Lamai, our cell diagram is little bit different. The cell diagram is going to be little bit different. Here, you don't use a direct beaker. You need to use a plastic cup. What you use? You use a plastic cup. There you go. Plastic cup is there. In the plastic cup, you put 2 holes at the bottom. And fix 2 carbon electrodes. What you fix? 2 carbon electrodes. So here, carbon electrodes are fixed from the bottom. The remaining, any leaks, you cover the leak using clay or silicon gel. Using clay or silicon, you cover the leakable spaces there. Leakable spaces are covered with clay or silicon gel. Next, you keep 2 boiling tubes upside down. There you go. 2 boiling tubes upside down. This. Now what? Connect the positive and negative terminal. There you go. What is our electrolyte this time? Aqueous H2SO4. There you go. H2SO4 aqueous. So inside this, you originally have what? Water. Acidified water is there. You all tell me first of all. Aqueous H2SO4. What are the ions present? H plus, SO4 2 minus, next OH minus. These are the ions present. What will the positive ions do? They will go to negative terminal. What's the only positive ion in the solution? Then H plus will go to the negative terminal. There you go. Negative terminal and undergo reduction. So negative terminal is your cathode. Positive terminal is your anode. There you go. H plus will go to the negative terminal, undergo reduction. Then what is your reduction reaction? 2H plus plus 2 electron H2 states aqueous gas. So what gas is produced at cathode? Hydrogen gas. Then what you will observe, there will be some gas bubbles evolving, and due to downward displacement of water, gas will be filled in the top. What gas gets filled? Hydrogen gas. There you go. There you go. Hydrogen gas. H2 gas. I'll take the volume of H2 gas filled here as 2V. 2V. Wait, 2V. 2V is the volume. Just wait, I'll explain. Now tell me what will happen to the negative ions in the solution? It will go to the positive terminal. Out of sulfate and hydroxide, who can undergo oxidation? Then what's our oxidation reaction? That one. 4OH minus convert to 1 oxygen, 2 water, 4 electron. What are the states? Aqueous state, gas state, liquid state. This is your first reaction. This is your second reaction. Now tell me, what gas will evolve at anode? Oxygen gas. There you go, oxygen gas. Water will displace down, oxygen gas will evolve up. You have oxygen there. Now, Lamai, the volume of oxygen gas will be V. That means if this is 20 volume, 20, let's say 20 centimeter cube. What is the volume here? 10 centimeter cube. Here, if it is 100 centimeter cube, here 50. So here, if you have 2V of volume, here you will have only V volume. You ask me what's the reason? Okay, what we are electrolyzing? Water. Water is H2O. 2 hydrogen, 1 oxygen. What? 2 hydrogen, 1 oxygen. That means when you electrolyze, you have 2 times the hydrogen, 1 time oxygen. 2V volume for hydrogen, 1V volume for oxygen. Again, see, water electrolysis, 2 hydrogen, 1 oxygen. During electrolysis, you actually break it. 2 hydrogen broken means 2 hydrogen will go. 1 oxygen means 1 oxygen will go. So when 2 hydrogen bubbles evolve, only 1 oxygen bubble will evolve. That means if you have 2 volume of hydrogen, how much of oxygen will be there? V volume. Clear? Understood? There you go. Final electrolysis. Final electrolysis. Draw the cell, write the reactions. For this one, try to write the redox reaction also. Try to write the redox also. See now, slowly we are developing. Try to write the redox also for this. You all write the redox also for this. Back row, can you hear? Ah, what you do? First one and second one. First one and second one. Can you directly add? Why? Number of electrons are not same. What you do first? Multiply the first one by 2, add it to the second one. Multiply the first one by 2. I'll do it there itself. No? Right. First one, multiply by 2. What you have? Plus. I'll name it as star. Now what you do? Add star and 2. Right hand side. Next what? What you have finally? Can you take one more step ahead? Why? 4h minus 4h plus. What you do? Converting to cancel. Converting to one oxygen. Correct? No? Hydrogen evolves, only one oxygen evolves. When two hydrogen gas bubbles evolve, how many oxygen gas bubbles should evolve? One. See? Two hydrogen, one oxygen. Clear. So basically, when you electrolyze water, can you see? Finally, in our equation, what we have? Water. When you electrolyze water, it converts to one oxygen to hydrogen. So basically, this is electrolysis of what I told you. Even though we add acid, there is no any influence from the acid. This is the reason. Finally, we have what? Only this. No, you can't see the acid here. Water is there converting to oxygen and hydrogen. Clear? Understood? That's all the electrolysis processes. Now we write a summary note on all of them. What are the electrolysis processes we learned? First one, sodium chloride, liquid, fused sodium chloride. Second one, sodium chloride, aqueous. Third one, copper sulfate, aqueous. Fourth one, water, acidulated water. There you go, cell diagram. Next, of course, ions in the solution. Oxidation reduction. Oxidation reduction. Right. First, what was our cell process? Sodium chloride, liquid. Tell. So now all of you should answer. Sodium chloride liquid. What are the ions in the solution? All. Who is going to undergo oxidation? Who is going to undergo oxidation? Cl minus. What's the reaction? It's until aqueous the no water, liquid and gas. Then who is going to undergo reduction? Who is going to undergo reduction? Yes, sodium plus. It will gain convert to state here. Now the cell diagram. You can't use a what you call beaker because it's done at a very high temperature. But we just do it. We just show it theoretically that you can do it like this. What's our electrolyte? Electrodes are there connected to the positive, negative, positive terminal, negative terminal. Negative is going to be anode to cathode. Negative is going to be, I'll write only C. Negative is cathode. Positive is, that's it. We all do for sodium chloride aqueous. Yeah, sodium chloride aqueous. A special point I give. Industrially, when you are performing, what is that cell called as? Yeah, go to the next one also. Sodium chloride aqueous. Sodium chloride aqueous, what was the special point? I told you we start at sodium chloride, finish at. Write the special point also. Work. Check. Can hear? Can hear? Can hear? Back row can hear? Check. Can hear? Can I hear me? This is liquid state. Some of you have the doubt why here liquid and here liquid. Usually sodium is a solid, no? Why here liquid? Lamai, we are doing electrolysis for sodium chloride liquid. Tell me, can you have sodium chloride liquid at normal temperature? No. You need to actually heat it above 800 degrees Celsius to do this reaction. Then only you can have sodium chloride liquid. At 800 degrees Celsius, guaranteed sodium will also be present in liquid state. That's why they are liquid. Okay, due to that high temperature. Second one, finish. Right, NaCl aqueous. First of all, what are the ions present? NaCl aqueous. What are the ions present? Na plus, Cl minus. What else? I'll write it here, no? More easier to see. Na plus, Cl minus, H plus, OH minus. Tell me, oxidation, this reaction, oxidation, no? Out of Cl minus and OH minus, who will undergo oxidation? Cl minus, now aqueous state, will convert to Cl2 plus 2 electron. Who will undergo oxidation? Who will undergo reduction? Na plus or H plus? 2H always, no, not here. There 2H plus will gain 2 electron, convert to H2. Aqueous gas. Aqueous gas. Aqueous gas. Aqueous gas. Now what? Cell diagram. What's the electrolyte? NaCl aqueous. Electrodes are there. There you go. Carbon electrode. Positive, negative. Positive terminal, negative terminal. Negative is going to be the cathode. Positive is going to be the anode. That's it. Cell diagram. What's the special point about this? Used to produce sodium hydroxide. Right here. Produces NaOH. Produces NaOH. Produces NaOH. Go to the next cell. Next one, what? Copper sulfate aqueous. Do. Finish. What are the ions present? SO4. What else? Hmm. Who's going to undergo oxidation? Why not SO4 2 minus? I told you already. So OH minus will undergo oxidation. Tell me the reaction. States. Reduction reaction. Copper. Cu2 plus will gain 2 electron, convert to copper. Aqueous solid. Now draw the cell. Now draw the cell. There you go, electrolyte. Copper sulfate aqueous. Positive, negative. Positive terminal, negative terminal. Cathode is there. Anode is there. What's the special point? What can you tell about the blue color intensity? We'll write it in short. Blue decreases. What else? Reddish brown. Reddish brown. Precipitate. Precipitate. That's enough. We'll write it in short. Next. Oxygen evolves at anode. That one is most important. Huh? Oxygen evolves at anode. Last cell is a little bit different. Do that also. What is our last one? Acidulated. water. What's the acid? H2SO4. What are the ions? Shh. They will undergo oxidation. Sulfate can't. Then what's the reaction? Same. States. What is going to be the reduction reaction? States. Cell diagram is little bit different. Positive, negative. Negative terminal, positive terminal. What is our electrolyte here? H2SO4 aqueous. What gas evolves? Negative terminal is anode or cathode? Cathode. Positive terminal. What gas evolves at cathode? What can you tell about the volume? 2 times the volume of oxygen. There you go. When drawing also make this 2 times and this time this one only 1 time. Then it's more clear. It's more clear. There you go. All the electrolysis processes in one chart. In one chart. All the electrolysis only who are there. All the four in one single chart. Today's second plan are also over. Electrochemical cell also over. Electrolysis also over. Now tell me, what do you feel about electrolysis process? Later by later. Later by later. Later by later. Later by later. There you go. A, B, B, A. Next. E, A, S. There you go. Patta is A. Patta kashto na. Okay. What we have now? Only electroplating is remaining. Take a 5 minutes. Water. Don't get up. You can't get up. Huh? You can't get up. Just 5 minutes and we'll start electroplating. 5 minutes and we'll start electroplating. Electrolysis process, you can ask. Right. 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 Only one more thing remaining for us today. What is that? Electroplating. Write down the next heading, electroplating. 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 Right. All. Right. 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 In electroplating, what you do? Let's take you have an object, for example, a ring. But the issue is ring is made of iron. Huh? That street shops you have iron ring. So you have a ring made of iron. Iron கொஞ்சம் அடி வாங்கி. You have an iron ring. There you go. Iron ring is there. Iron ring is there. Ring is made of iron. Ring is made of iron. Do you like to wear iron ring or copper ring? I mean, you all like to wear copper ring. You all like to wear copper ring. Right? Because more than iron, copper is less reactive. That means you can use it for a long time. If you use iron nail, after some time it will rust and you will be finally ending up with a rust nail, not a iron nail. So then what you need to do is you need to apply copper onto this. You wanted to apply copper onto this. Copper on this surface. There you go. Copper on this surface. Outer surface, inner surface, everywhere. You wanted to apply copper. What can you do? Take a paintbrush, put it in copper, apply. No, you can't do that. For that process only, you use a method called what? Electroplating. So you basically use electricity, electric current, and plate a metal on another object. For example, copper on iron ring. You are going to plate it. Clear? That is what you do during electroplating. Lamai, here I will be using some important keywords. I will introduce those keywords. The iron ring is going to be object to be plated. What are that? Object to be plated. So if I tell object to be plated, that is the object. That's the object. The metal that is used for plating. The metal that is used for plating, that is going to be metal used for plating. Metal used for plating. For plating. Right? So here, what's the object to be plated? Ring. What's the metal used for plating? Copper. Metal used for plating? Copper. Object used for plating? Iron. Now, Lamai, to do electroplating, there are 3 important things that you should know. Point number 1. Object to be plated. Object to be plated. Object to be plated. Observe. Object to be plated should be your cathode. Should be your cathode. Look at the electrolysis process. Cathode is negative or positive? Negative. Then the object to be placed should be plated should be placed where? At negative terminal. Second point. Metal used for plating. What? Metal used for plating. Metal used for plating. Guess and tell me. Metal used for plating should be used for plating should be your anode. Should be your anode. Anode is positive or negative? Last point. The electrolyte. The electrolyte. There you go. Electrolyte should be a aqueous solution of the salt of the metal used for plating. Listen, will you? Electrolyte should be a aqueous solution of the metal used for plating. Aqueous solution of salt of metal used for plating. Salt of metal used for plating. Metal used for plating. I know you won't understand it in that way. I'll break it and teach. See, electrolyte. What is the electrolyte? In the beaker, the solution that you fill, electrolyte should be what? Aqueous solution of salt. That means you take a salt, you dissolve it in water. It should be an aqueous solution of salt. What salt? Salt of the metal used for plating. Lama, here tell me. What is the metal used for plating? Copper. Tell me a salt of copper. Copper sulfate. So what is going to be your electrolyte? Copper sulfate aqueous. That is what they tell. Clear? Understood? Only copper sulfate is only there in our syllabus. In case if they ask for any other thing, if they tell silver, if the silver is the metal used for plating, then the salt is going to be silver nitrate, something like that. So you add it with another negative polyatomic ion and then write the formula. So here copper sulfate, silver means silver nitrate, something like that. Clear? However, they won't ask about silver and all. If they are asking, they will give salt of silver, silver nitrate. Usually they ask about copper, then copper salt is what? Copper sulfate. So your electrolyte should be guaranteed aqueous solution of copper sulfate. Clear? Let's write down electroplating. Electroplating. Under that, coating a metal coating a metal on an object by passing electric current is electroplating. Draw this. Now write down special points. Special points. You're almost done. Today you can finish by 3. Finish by 3. We went faster than my calculation. So those who have the train can go, I think 3:30 something, there is a train. No, 4 there is a train. Colombo people, 4 there is a train. Others can stay, talk and go. I'll be leaving to Colombo by tonight. Right. Right. Electroplating will go with the same example. Electroplating copper on iron. Copper on iron. Copper and iron. What are the special points? Object to be plated should be cathode. That means iron ring should be your cathode. Material used for plating should be your, then copper should be your, electrolyte should be, there you go. You have the solution. Solution is guaranteed what? Copper sulfate aqueous. Object to be plated, iron ring should be a cathode, that means connected to the negative terminal. There you go. Positive terminal, negative terminal. To the negative terminal, I will connect a ring. Iron ring. Ring is connected. Ring is connected. Next. Material used for plating should be your anode. Anode should be connected to the, there you go. I connect a copper rod there. A copper rod there. A copper rod there. You all tell me, what are the ions in the solution first of all? Copper sulfate means CO2 plus SO4 2 minus aqueous state, and what is going to happen? Positive ions will go to the negative terminal. Negative terminal is going to be a cathode. So at cathode they will undergo reduction. Negative ions will go to the positive terminal and they will undergo oxidation. That's the anode. I know this is what you will think. Okay, I will also think in that way and do. Okay, right. Tell me what is going to be the reaction first of all. Copper 2 plus is there, H plus is there. Who will undergo reduction? Tell me the reaction. State. Reduction, no problem. Issue is with the oxidation. Ah. Usually who will undergo oxidation? Someone who is more reactive. Someone who is more reactive will undergo oxidation. But here we have an issue. H minus is there, sulfate is there. Other than that, you have a reactive metal. Who is that? So more than these two, who has the ability to undergo oxidation? Copper. Then who will jump into the solution? Now copper will jump into the solution forming copper 2 plus iron by leaving 2 electron. There you go. Copper will jump into the solution forming copper 2 plus by liberating 2 electron. Solid state, aqueous state. So what is actually happening here? See, it's a cyclic process. Copper from here jump into the solution forming copper 2 plus. Copper 2 plus going to the iron nail and becoming copper. It goes to the iron nail, get attached on the iron nail or iron ring and coats copper on it. Clear? So copper jumps, forms copper 2 plus. It goes back again, gets attached there as solid. So jumps, goes, jumps, goes. Then tell me, will there be any change in the blue color intensity of the solution? No. Why? Whatever which jumps goes there. Is there any change in the number of copper 2 plus ion? No. If there is no change, will there be change in this thing? No. Will there be anything precipitated here? No. That is what is going and attaching here. Clear? Understood. Now, how to make this more and more effective? How to make electroplating more and more effective? See, in electroplating, we are trying to like paint, right? It's something like a painting process. When does painting becomes more and more better? See, if you have a painter painting like this on the start, will it be better? No. Another painter is there, fellow is doing it slowly. Slowly fellow is doing. Slowly fellow is doing. Slowly fellow is doing. Which painting is more better? First or second? Why? In second one, process is slow. So if you slow down electroplating, the electroplated object will be more and more better. How to slow down this process? Slow the rate of reaction. How to slow the rate of reaction? Reduce the concentration. So here you need to use a less concentration of copper sulfate. So by reducing the concentration, you reduce the rate of reaction. That means you slow down the reaction. If you slow down the reaction, electroplating will be more better. Another way, reduce the voltage here. If you reduce the voltage here, electroplating will be slow, then it will be more better. Clear? Understood? That's all electroplating done. We'll write. Draw there this diagram. Draw this. You can't see that part, no? I'll come. One second, one second. Finish. Another write down. Another write down. Last point for today. Another write down. So better electroplating. For better electroplating. For better electroplating. For better electroplating results. For better electroplating results. For better electroplating results. For better electroplating results, tell me what are things you should do? Reduce the concentration, reduce the voltage, right there. Under that, first one, reduce the concentration of the solution. Reduce the concentration of the solution. Reduce the concentration of the solution. Second one, reduce the voltage supply. Reduce the voltage supply. Reduce the voltage supply. There you go. All the three parts that we planned for today are done and dusted. Anyone with a doubt, even if there's a single person with a doubt, anybody, at least is there a single person with a doubt? Still not over. Wait. I told three now. Anybody with a doubt? I come. Okay. Shh. 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 Settle down. All settle down. Right. There you go. Second seminar that I plan to do. First seminar was last Poya day at Colombo. Second seminar that is for the Candy people, that is also done. As you all asked, geometrical optics was done for the Colombo people. Electrochemistry, the main three things: electrochemical cell, electrolysis, electroplating, together with the summary points, done and dusted for you all. After this also there might be some seminars. Is all of you are there in the WhatsApp groups? All the information given will be given through the WhatsApp groups. Plus, today I will consider, you have the names now? We'll consider the people who misbehaved. They can't enter the seminar next time. They can't enter the seminar. Even if it is free seminar, even if it is paid seminar, they can't enter my seminar. That is one point. Because Lamai, what is your main aim now? O-level exam goda podradhu. O-level exam කොහොමරි ගොඩ දාන එක තමයි දැන්ට plan එක. Then you should work for what? For that. Even if you don't work for that, you should allow others to work for that. Always keep that in mind. Even if you don't work for that, you should allow others to work for that. Because there are so many others who wanted to work for that. Especially the girls. I told you boys, I think boys gone to the our generation lost boys bye tamai. Very hard to find a can't I bet. That's why I think now itself so many people are finding. For sure, after A level, after A level, once when the girl enters medical faculty and once when you start Uber driving, there will be issue there. Those who are having now, a issue will be there. So what should the boys do? At least to maintain it, study. At least to maintain it, study. That is number one, right? Now, Lamai, we have another, how many days? Exactly 40. 40? We'll round it off to 40, will you? We have 40 days on hand. We have 40 days on hand. My question for you all is, what can't we do in 40 days? What can't we do? Lamai, we can do many things even in one day. Then we have how many days? 40 days. I know your third term marks. Sir, don't ask about that. I know what your principal sir told you all. I don't believe this batch. Utter worst batch in my career. I have never seen a batch like this. Next time also will tell the next batch also same. So many teachers would have motivated you, but sometimes there might be a drop from there also. At houses, once when you go home with the report, parents meeting is also there. No, that is also there. After the parents meeting, report is also given. From the school itself, everything starts. It will take a cotton bud. No. Next time, anything after you can't take a cotton bud. From there until home. The question is this. The talk from the home is this. What did you do a whole night? Even I made coffee and I woke up at 4 o'clock to wake you up. What did you do? Marks about? I don't believe you. That will be the sounds that are coming in the houses also these days. Maximum. Even during my time, there are those sounds came. So remember, that will be coming. What will your sister brother do? Do during my time, I you don't know. We used to even keep mixing the you would have never seen that person like that. Really like that. I know most of the people would have lost the hope on you, but you never lose the hope on you. That is what is to be done. First thing that you should have is the self-confidence. Yes, karna. However, I do. Now, 11 years we work for what? For this. Another 40 days are there. Between these 40 days, if you work properly, guaranteed better results. Guaranteed better results. I'm telling to the boys also. I know you never worked until now. No? 40 days are there to catch girls. No double meaning. Girls the same. 40 days are there. Never leave a boy overtake you. Have a competition. Especially have a competition inside yourself first. I will perform to my best. Yesterday I got a call from a parent. Sir, my child rank is dropped. I wanted him to take high rank. Lamai, can we make you all for ranks? No. There is a best in you. You should work for that. Rank is just a system of comparison in schools. That's it. It's just to compare you with other students so that parents have a point to scold. That's it. That's the main theory behind it. You should have your own competition. More than the last time I work more. More than yesterday, today I will move. More than the last hour, I will work more this hour. Guaranteed what will happen. Your life will be taking a huge upward motion. I know most of you now, flat is there. Sometimes drop is there. Like that, the life is going. If you properly work for the next 40 days, that is more than enough to take a huge upward motion in your full life. Not only for A O level, just after that also. Then how to work? Be like robots these days. Lamai, if you don't be like robots now, you will have to end up being robots in the remaining part of your life. Early morning getting up, there's a huge work to be done. Still, you can't earn in Sri Lanka, of course. You can't earn. Full day you need to work, be like robot. Whole life you need to spend, and finally we die also like that. That is our typical Sri Lankan life, no? I wanted you all to step out of it and live your own life. That means if you wanted to buy something that you like, you should have the money and you should have the willingness to buy it without thinking twice. That is what you call as living. I don't tell go and buy the unwanted things. So that you should have the wisdom to select what you should buy. But you should first build yourself, your family, and your surroundings so that what you like, you can do. That is life. For that, what you should do, you should work. This 40 days, be like robots. That means early morning get up. Let's take average. In an average, you get up by 7 a.m. Within the 30 minutes time period, do all your work and complete morning work. Exactly at 7:30, exactly at 7:30, you start your work. At the top tier work. First 2 hours, if you can work like that, guaranteed your whole day will be productive. In case if you miss this, okay, I'll take my WhatsApp a bit, I'll text her. She will never text, she is studying. Text her. You will wait for the reply, lunch. Okay, then you think lunch, I'll sleep a little, whole day will become a waste. If you wanted to make the whole day productive, first 2 hours, work in a productive way. From there onwards, select what are the other things to be done. Afternoon time period, do a paper. Why? That's a sleeping hour for everyone. Any person, that's a sleepable hour, afternoon hour. So at that time, do something that you can just do without stressing your mind. Take a MCQ paper or something. Do. Again in the evening hours, put your fullest. By about 7 p.m. you are done. After that, take some time to appreciate yourself. You work for the whole day. Appreciate yourself. If you work like this for the next 40 days, guaranteed superb result. I'm talking to the people who are at S and W levels. You can go for A, man. Not only in science, all the other subjects. Just think. The people who told you will get W, you take a A and show. Why? You can close their mouths, huh? You will be the king of your house. Phone. Huh? Food on time, on the table. These days, what do we tell? Go and eat. Food on table. All those things you can get. Plus, your life will be patta beautiful. And you can carry on that work. After that, you will never think, okay, I will not work for today. I will just spend some time, not like that. After that, every day you wanted to work. If you work like that, guaranteed you can go to a top. You don't need to become the richest person. However, the rich community in the world is out of 100%, only 1%. Only 1% out of the 100% is in a stable community. I won't tell rich community, it's in a stable community. That means if you want something, you can buy from your money, not your father's money, not your mother's money, what is there in your bank from your deposit, your money. That people, only 1% is there in the world. Get into that 1%, that's all. After that, going up, becoming patta rich person is your thing. First of all, get into that 1%. That's what you should do. Can you all work fullest in the next 40 days? I can't hear. Can you all give you 100% in the next 40 days? Will you work from the morning until the evening? Good. Now tell me, what do you feel about electrochemistry? What do you feel? Letter by letter. Letter by letter. There you go. Letter by letter. Letter by letter. Start. Give me a. Next. 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 Next letter. Next. 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 There you go. Patta is and the signature. See you all again with a patta result. Work hard. Bye. Wait. How are we going to send? One shot, no? This row remain. This row can go. Those who wanted to stay and talk can stay and talk. First this row. And once when the crowd reduces, this row. Well, manage and go.